Good morning, everyone. Today we are going to discuss about a topic that is about the thermal destruction of. We will be talking about thermal destruction of microorganisms. Okay, this will be my number, lecture number 30. Thermal destruction my lecture number 12. Okay, my lecture number 12 is about thermal destruction of microorganisms. Why specifically this will be this gives an insight of what are the different values of I'll be taking the outline of the lecture is, and this the outline of the lecture is like what is the thermal death kinetics we have, what are the values, that is the D value, the Z value, the F value, what are the values. Okay, then the 12B concept we will be touching soon. So basically what I will be doing is I will be just taking the this type of concepts in a very crisp manner, and we will be solving one or two problems. And that is how this lecture is has been scheduled. So what will be the concept? It is like what is the thermal death kinetics basically meaning with? Thermal death kinetics is basically we are heating the food at a particular temperature and for a particular temperature and time. Okay, so this particular thing, that is thermal death kinetics. Now the subtopics will be just talking in broad crisp, that is D value, Z value, F value, and 12P concept. So basically this thermal death kinetics is depending on three factors that are nothing but the time temperature. What is the time temperature relationship we are having here? Then the particular resistance, the thermal resistance on the targeted microorganism of targeted, that is T, targeted microorganism, and what is the concentration of the microorganism. Okay, so this particular these are the factors on which it is based on. And another thing is it is mainly based on the first order kinetics, that is first order reaction we have. First order reaction will be based on these are the this will be first thing. Next it will be like what will be the next concept will be what is D value. Okay, what do you understand? What do you mean by the D value? It is nothing but the time required to reduce one log cycle. That is like if I am talking about the D value, so we will be talking about D value, then Z value, and F value. So D value, the simple concept you can say, it is nothing but we will be telling about, that is one log cycle will be reduced. Okay, 90%. That is one log cycle reduction. The time that is taken to reduce the one log cycle, time required to reduce one log cycle. Say for example, from 10 to the power 5, it reduces to 10 to the power 4. Okay, this is the D value you can see. Now this thermal first order reaction it follows, as well as what happens is first order reaction they will take, as well as they will be taking the logarithmic curves. They follow the logarithmic curve, that is this. Okay. what happens is this way they will follow the logarithmic curve. That is in time in minutes and number of microorganisms, time in minutes. Okay. So basically that depends upon again three factors, that is temperature, microorganism and the medium. So it will depend upon the three factors: temperature, microorganism and medium. So at a constant temperature, the time required to reduce that particular one log cycle, 90% of the microbial population, that is called as D value. Okay. Next, what we will know is we have the function is like dn by dt is equal to minus kn, that is your thermal death rate constant. K is a thermal death rate constant. So if you express it in the form like n equal to this integrated to n0 into minus k to the power t. This will land your second equation, and this is your first equation. Okay. So then what we will do is, what is the time taken? Time is nothing but d log n0 by n. This will be the time. So if you are aware of the t value, so what is the time? You need to find out the d value, and you are given the n0 and n values. You can find out the d value, or either of the values is given. You can find out the, if initial population is n0 and the final population that is remaining, that is the n. Okay, that is the population at the period time t, and d is the decimal reduction, that is d value. So this, if you know, you will be able to find out if the values are given for, and you can find out what is the time or what is the decimal reduction, that is the d value. Okay. Now, what do you understand? So from here, few things you can take it as a small question. That is, it follows the first order reaction, thermodynamics. It is having a logarithmic process or logarithmic process that is linear. That is the graph you have, which is number of microorganisms versus the time taken or time in minutes. Okay. Then we will be having about the that is next part will be the Z value. What do you understand by Z value? Z value is nothing but the temperature change. Whatever the temperature change you are having, okay, the temperature change is a function of that it is measuring. For T value, it is time required. It is the temperature. That is the change in the temperature in, you can say, in the change in the temperature or the temperature that is required to have a change in tenfold in the decimal reduction time, D value. Reduction time. Okay. So the heat resistance force will be mainly having 10 degrees Celsius. Okay. And for vegetative spores, we have the Z value as around 4 to 8 degrees Celsius. I'll quickly write down some of the like microorganism pigments, what are the Z and D values of that. That maybe in some cases it is important. So for bacteria, if you say what is the D and what is the Z value. For bacteria, it is 5 to 10. And for this is the D value is around, D value is, you know, it is measured by, it is the time. So you will be having it in minutes, right? And this will be in degrees Celsius. So it is 1 to 5 minutes, and mainly it is 5 to 10 degrees Celsius. Similarly, if you have enzymes, enzymes will be around again 1 to 5 minutes. You will be 30 to 40 degrees Celsius will be your Z value. If you have some pigments, so pigments are basically having the D value as 150, 150, 200, whereas this is around 20 to 150 to 200 minutes, and the Z value is around 25. For vitamins, if you talk about, okay, so the thing is around 15 to 20 minutes, and we have 40 to 70 degrees Celsius for the Z value. Is it clear? So you can keep a note of few that what is the approximate temperature, Z value, and D value of this particular bacteria, of the bacteria, vitamins, pigments, as well as enzymes. So the next point we will talk about the F value. What is F value? F value is nothing but the number of minutes, or that is mainly the time only, the number of minutes to kill the population by a factor of 10 to the power 12. So for it is 1 log reduction, and here we will be having D value is for 1 log reduction, and here the factor number of minutes that is required to kill the population, okay, by a factor of 10 to the power 12, right? So that is the 12D concept which we are having here. Now the F value, usually whatever we are keeping the F value, the processing time. Suppose we are keeping a particular material in the can and going for retort processing. So the processing time always should be, the processing time should be greater than that of the F value, okay? And what do you understand by lethality? Lethality is nothing, or it is also called as sterilization effect. That is nothing but number of decimal reduction in number of microorganisms. Okay, the number of decimal reduction, that is lethality. How many decimal, whether it is 1 log cycle, whether it is 2 log cycle, the number of decimal reduction in the number of microorganisms, that is called as lethality. Okay, now, so with this, we will be, so the basic things are what? What is D value? What is thermal death rate constant? What is D value? What is F value? What is lethality or sterilization effect? What is the Z value? Okay, these factors we will be, these basic concepts you are aware of as of now. Now, another graph we will usually have, if you know the D value, one more graph I have to explain, then we will do some. Suppose this is the graph you are having for D value, and this is your temperature. Okay, so maybe here it is 90. No, just here you have 0.5, 1. Like, so what happens? If we plot it like this, okay, there will be at this point there is a reduction at 90 if you are having at this point, okay, and at that the other point you are getting for 100, right? So what is the Z value here you are getting? The Z value here you will be definitely, it will be like 100 minus 90 you will have. So we need to plot from the temperature and the D value, we can find out the Z value from this curve. So it will be 10 degrees. Okay. Now, quickly I will just first I'll give a small, or I will summarize it in the nutshell. Okay. Once I summarize in the nutshell, what are the things we have done this, like it is following the basic logarithmic process, then it is in the thermal death rate, what is the D value, F value, as well as Z value, what is the lethal effect. Okay, now some of the important formulas I will talk about, and then we will take some important formula which you should know. Okay, So the important formula, and another thing we will be telling is the spoilage probability. There are often numericals on spoilage probability. For the spoilage probability, we have we have derivation. From there, we derive that is 1 by r is equal to N0 is the initial population of 10 divided by the F by T value. So from here, you can find out what is the spoilage probability. Okay. So this is one formula. So here we can take it. Number one. Number two will be your the important formula we can say is N is equal to N0 minus KT, where this is the thermal depth constant. K is thermal depth constant. Third formula we can talk about the D. D equal to T by log N0 minus log N. Okay, this is another formula to be. These are the important formulas which I'm jotting. You can do this. N by N0 is equal to 10 to the power minus T by D. Then fifth one is F E equal to N dt. Then the sixth formula is like Z value is equal to T2 minus T1 divided by log of D1 minus log of D2. Okay, so this is the other formula, and then for seventh one we can see this spoilage formula I have already said you. Okay, the seventh one is Z is equal to 2.303 R divided by activation energy, that is VA T1 T2. Okay, then one more formula, that is the eighth one, is F R by F ten to the power minus 3R by Z. Okay, so these are the formulas which you can say the first spoilage probability. Then you have this the initial second one initial the thermal depth constant you are aware of the time. So the population at one particular time, the initial population you are aware of. If you have to find out, this is the second formula. Then the third formula is about the T value. Okay. Then how to find out the Z value if this particular time temperature and activation energy is given. So same goes with the Z value and F value, how you can find. So these 8 formulas, if you are much aware of, then we can solve maximum of the problems, because that mainly comes with some like this mainly covers this formula mainly cover all of your numerical problems majorly. Now what we will do is, so these formulas, what is D value, what is the graph explanation. Okay, so if all that you are aware of, that will serve the purpose, because this topic is usually going for competitive exams, and even you will be asked in some interviews and what is D value, what is Z value. So you should be in a position to answer those. But for written exams and all, definitely you will be any of such exams. This is one of the very, very important topics from where you usually get numericals regarding your D value, Z value. Okay. So now what I will do is I'll take 2-3 problems from gate question papers. Okay, and we will solve it. Just to see how the how the formulas are getting applicable there, and we'll based on that we'll solve 2-3 problems, and then we can wind up. The first problem will be from GATE 2017. Okay. Here what all we are having is, we have two microorganisms. Two microorganisms are there, A and B. Okay. So the D value is 121.1 degrees Celsius for both. Now the A value, the N0 for organism A, it is nothing but 2 into 10 to the power 4. Okay. You can copy the question like, a suspension is containing 2 into 10 to the power 4 spores for organism BA having B 1.21.1 degrees Celsius and value, and that the time is given as, for this organism A, the time is given as 1.5 minutes. Okay. And the other time which we are giving for organism B 0.8 minute at same degree, D 121.1 degrees Celsius with N0 as 8 into 10 to the power 5 spores. Okay. So we need to find out the spoilage probability. The probability of spoilage, that is 1 in 1000, is how much? Probability of spoilage. That is nothing but, you will be probability of spoilage, that can be given by 1 by R. So we have to use the first formula here, that is nothing but formula 1 which we have discussed just now, formula 1, that is 1 by R is equal to N0 by 10 F by D. Also we can use this formula also. Yes. So that is the one which is the spoilage probability formula which we have discussed just immediately before this. Okay, so 1 by R we are not aware of. We know what is for organism A. First we will find out, and same will go for organism B. For organism A, what is N0? It is 2 into 10 to the power 4 divided by 10. F is what? F we need to find out. Okay, the spoilage probability is what? Probability of spoilage, they have said 1 by 1000. Okay, 1 by R is 1 by 1000 given in the question. So that is equal to 2 into 10 to the power 4. Yes, here we have to write that is F by 1.5 minute. Okay, so when you are solving this, so it will come like F by 1.5 is equal to giving you log 2 into 10 to the power 7. So with the log rule, you will be having what? Log 2 plus log 10 to the power 7. So if you solve this sum, you will get F is equal to 7.301 into 1.5, which is 10.95 minutes. So you got the first one. Similarly, you need to do the second one. For second probability, that is for organism B, the same formula will be applied with nothing but 1 by R is equal to N0 10 to the power F by D. Same formula will be applied 1 by 1000. Here your N0 will differ as 8 into, what was the value we gave? 8 into 10 to the power 5 divided by 10. F is not known here, and D we have 0.8 minutes. So when you solve this numerical again the same way, you will be getting the value as F is equal to 7.12 minutes when you solve it. Okay. So same way, that is nothing but 1 by 1000. Okay. So this we will be getting 10 to the power F by 0.8 is equal to nothing but log of 8 into 10 to the power 5. Yes. So from there, F by 0.8 equal to 8.90 into 0.8. We are multiplying that. So we will get 7.12 minutes. So in this, we can conclude that A and B will heat in 10.95 as well as 7.12 minutes respectively. So the maximum time that is required to obtain the probability maximum time will be referred to as, that is for organism A, which is to obtain the probability spoilage, that is 1 in 1000 is 10.95 minutes. This is the idea of the first one. Okay. Now the second numerical we will be talking about. The second numerical goes like, it is a GATE 2016 question. Okay. We can say like the D value and Z value for Clostridium botulinum is 0.2 minute is the D value, and the Z value is 10 degrees Celsius. Okay, the total time required in minutes. What is the total time? That means it has been asked for finding out total time means your F value. So the question itself, D value, Z value is given. You have been asked to find out the total time to reduce the spores from, spore is like spores from 10 to the power 2 to 10 to the power minus 6 at 111 degrees Celsius is how much? Okay. So D value for and Z value for Clostridium botulinum is 0.2 minutes for 10 degrees Celsius. The total time of the F value is given. We need to find out the total time, that is F value. Okay. The total time required in minute to reduce the spores from 10 to the power 2 to 10 to the power minus 6 at 111 degrees Celsius is. So let's find out the solution, how it goes. F value is the time taken to kill a particular population of microbes at a specified temperature. Misha, we already know. What is F value? That is the thing. Now F0 is nothing but B0 log A minus log B, where log A is the initial population. Okay. And log B is nothing but the final population. And this B0 is the decimal reduction time. Decimal reduction time. So as per the formula, we can come the, now when we are putting the formula, it is F0 by F0 by Ft is nothing but 10 to the power T minus T0 by Z. We have discussed the formulas. Okay. Now, where F0 and T0 are the reference A's and values and temperature, that is given. Na? What is the reference one? F values and temperature, that is 121 degrees Celsius. So in order to find the value of F0, what will you do? We will be telling F0 equal to 0.2, that is the log D value. Okay, then this is D value. We are putting this formula, we are finding the F0. So this is the first formula. Putting the formula here, F0 equal to D0 log A minus log B, that is 0.2 is the D0. Log A is the initial population 10 to the power 2, and log B is the final population, that is 10 to the power minus 6. So when we solve this sum, we will get 0.2, and this is locked into there 2 and 2 plus 6. From there, we are getting F0 equal to 1.6. Now already we found F0. So my second point is putting that F0 value in Ft in the second equation or the second formula. So 1.6 divided by F111, F at 111 degrees Celsius is nothing but 10. T is your 111 into the T0 is 121 divided by Z, which is giving you the F111 as 16 minutes. Put the value here as T value and the T0 value. Okay, whatever is coming. So you will be getting as the value as F11 as 16 minutes. Okay, the next numerical we will be doing, third one, and this will be the last numerical for this session. Another type we will do and find out how it is coming. Okay. So thermal destruction of microorganisms follows the kinetics of, what will be your answer? It will be first order reaction. Okay. I'm repeatedly telling because chances are often there, this type of question usually comes. Okay. Next, we will be having a small numerical. Third, the F value, third numerical, the F value at 121.1 degrees Celsius is equivalent to 99.999% destruction of Clostridium botulinum. Okay, is 1.8 minutes. Okay, the question is the F value of at 121.1 degrees Celsius equivalent to 99.999% destruction of a strain of Clostridium botulinum is 1.8 minutes. The D0 value, decimal reduction time at reference temperature of the organism. What will be the D0 value? We are known with F value. So what we can do here, we will be the solution of this particular numerical. F at 121.1 degrees Celsius is 1.1 minute given. So therefore, 99.9999% destruction, that is nothing but N0 equal to 100 and N will give you 0.0001, that you have to infer from this. Then what happens? We need to put the formula here and we can find out the formula goes like F equal to the same, D log N0 minus log N. So when you find the F is already there 1.8 minutes, D you are not aware of, log N0 is 100. Log 100 minus log 0.001. 0.001. Okay. So here we can substituting and after the calculation you will be getting 0. This is the V value. Okay. So in this the takeaway points will be your 3 numericals of the gate papers we have solved here, and along with that, what type of points we will be getting? What is Z value? What is D value? What type of and F value? What type, the formulas which we have discussed mainly. Those 8 formulas you can keep in mind, that is the spoilage probability, how to find the Z value, D value is given, how to find out the F value. So these 8 formulas you can try to keep in mind for solving problems. Then what for order of reaction do they follow? That is nothing but first order reaction. And it is also a logarithmic phase. Okay. So these particular things has been discussed here. Okay, then thermal death curve, what is lethality or the sterilization effect, what is spoilage probability. These points have been discussed here along with the 3 numericals from gate papers. So with this, I conclude my lesson here, lecture. This lecture is session by myself, Payal Gupta, research scholar, Department of Food, Agriculture and Food Engineering, IIT Kharagpur. Thank you so much.